Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 3 video on the chapter of heat transfer, where I will be discussing about superficial and cubical expansion of solids when they are heated. uh, in the part 1 I discussed about linear expansion of solids, and in part 2 I have solved some problems on the linear expansion of solids that was discussed in part 1. If you have not watched the previous 2 videos, then I strongly suggest that you please watch them to have a good understanding of the concepts and how to solve the problems. So this video is part of the playlist ICSE Physics for class 8, where I primarily discuss about key concepts and formula related to numerical problem solving. If you find this video beneficial, then please like it, share it with your friends, and if you want to further support me, then subscribe to my channel, and in that case do not forget to press the bell icon so that you will be notified by my future videos. So let's start part 3 video, where I will be discussing superficial and cubical expansion of solids when they are heated. Okay, so the concept of so the superficial expansion of solid plates. These are specifically for solids which are in the shape of a plate. That is, they have area. They have an area and their thickness is very less. So for plates like solids, it is mainly defined. So when a solid plate of an area A is heated through delta T degree Celsius, that is when the temperature of a solid plate of area A is increased by delta T degree Celsius, then the area increases. If the increase in area is delta A, then the formula we have is this formula, which looks very similar to the linear expansion. We are having delta A is equal to beta A delta T. Delta A is the increase in area of the solid plate. Beta is known as coefficient of superficial expansion, which again is specific to, it is a constant for for a specific material, and the value is different for different material of the plate. And A is the original area of the plate, solid plate, and delta T is the increase in temperature. So for superficial expansion of solid plates, we have the increase in area is equal to beta multiplied by the original area multiplied by the rise in temperature. Now the unit of beta is same as the unit of alpha. That is, you can see from this formula, you can see that beta is equal to delta A divided by A multiplied by delta T. So the unit of beta will be equal to unit of delta A, which is unit of area, divided by A, unit of A, which is unit of area, multiplied by unit of delta T. Delta T is temperature, so unit of temperature. So unit of area cancels from numerator and denominator, and we are left with 1 by unit of temperature. So the unit of beta, if you consider the unit of temperature as Kelvin, it will be a unit of beta will be per Kelvin. And if you consider the temperature to be in degree Celsius, then it will be per degree Celsius. So the unit of beta is either per Kelvin or per Celsius. Okay, so similar to alpha, what exactly is beta? It is increase in area for a solid plate. It is increase in area per unit original area per unit rise in temperature. That is, if you consider a solid plate of area, let's say 1 meter square, and of area 1 meter square, and if you increase its temperature by 1 Kelvin, then the increase in area will be beta meter square. This is the definition of beta. It is the coefficient of superficial expansion of solid plates. Now the second concept is now similar to alpha. How do we have the variation? We can from this formula that is delta A is equal to beta into A into delta T, you can easily figure it out how the values of delta A, beta and delta T are vary with each other. So if the beta and capital A, if the beta and A is kept constant, then we will see that the increase in area will be directly proportional to the increase in temperature. And if the original area and the increase in temperature is kept constant, then the increase in area will be directly proportional to beta. And finally, at constant beta and delta T, you will see that the increase in area is directly proportional to the original area. So this is all about the superficial expansion of solid plates. Superficial expansion means the expansion in area of plate-like solids, and here we have the coefficient of superficial expansion, that is beta. Okay, the third concept is cubical expansion of solids. Now, in general, solids which has 3 dimension, that is which has the length, breadth and height, for those solids, if you heat them, then their volume also expands, meaning their volume also increases. So the formula is exactly the same as linear expansion and superficial expansion. The formula is delta V. So if you heat a solid which is having an initial volume of capital V and increase its temperature by delta T, then the increase in volume, that is delta V, will be equal to gamma multiplied by V multiplied by delta T. So here V is the initial volume of the solid, delta T is obviously the increase in temperature, delta T is the rise in temperature, or when you are hitting the solid body, delta T is the rise in temperature, delta V is the increase in volume of the solid, and gamma is the known as coefficient of cubical expansion. Cubical expansion means expansion in volume. And from here you will see that gamma is nothing but delta V divided by V multiplied by delta T. So as you can see, delta V and V, the unit of delta V and V will cancel out, and we will have a 1 by unit of temperature. So the unit of gamma is also per Kelvin or per degree Celsius. Again, similar to alpha and beta, what exactly is gamma? It is increase in volume for a solid. It is increase in volume per unit original volume per unit rise in temperature. That is, if you have a solid whose volume is, let's say, 1 meter cube, and if you raise its temperature, if you heat the solid and raise its temperature by, let's say, 1 degree Celsius, then then the increase in volume of the solid will be gamma meter cube. Okay. Now the variation of delta V, gamma and delta T is exactly the same as beta and alpha, so I am not discussing it. Now an interesting thing has been found is that for a specific solid material, it is found that the ratio of the alpha, beta and gamma is always approximately equal to 1:2:3. So for example, for copper, you will find that alpha is to beta is to gamma is always equal to 1:2:3. So this is one important formula you must remember that relates the 3 coefficient of expansion, that is coefficient of linear expansion, coefficient of superficial expansion and coefficient of cubical expansion with a ratio. So that is all about the problems that can come from the chapter of heat transfer. So far I have understood. So based on this, based on the concepts that I discussed in this video, that is superficial and cubical expansion, and how alpha, beta and gamma are related to each other, that is the ratio is equal to 1:2:3. Based on these concepts and the concepts of linear expansion, I will solve in the next video few more problems, so that you have a good understanding of these concepts of thermal expansion of solids, and you can solve problems based on these concepts. So please stay tuned for the next video where I will do problem solving. That is all for this video. Thanks for watching, and I'm ending the video here. Until the next video, take care and bye.